All right, all welcome to 16.40 and negative exponents. So we've talked about the product rule for exponents. We've talked about the quotient rule, right? But notice they've all been positive exponents. That's normal, right? But turns out you could have an exponent that's a zero. You could have 10 to the zero power. You can also have negative exponents. You have 3 to the negative 2 power. Weird, right? So we're just going to talk about what those are and do a couple examples. All right. So what are we doing today? We're evaluating numbers with zero and negative exponents. So what is 2 to the 0 power? Most people will say it's 0. A lot of people tend to think it is 0, right? It's not. 0 is not the correct answer. Let me show you why 2 to the 0 power is not 0. Let me show you why it's not 2, why it's not 4, why it's not 8, why it's not 20. I will show you what it is in a second. So 2 to the 0 power. Let's just set up a random thing right here. So I'm going to put 2 to the 5th divided by 2 to the 5th. As soon as my iPad gets in drawing mode, and I can draw. Right? Almost there. Sending request. Let's just send it to the cloud, I think, and send it back down. Here we go. So I'm going to do 2 to the 5th divided by 2 to the 5th. Now, remember our quotient rule. These two are the same, right? So I'm going to do 2 to the 5 minus 5 power, right? Well, 5 minus 5 is 0, so I get 2 to the 0 power. Cool. Let's look at this a different way, though, right? 2 to the 5th over 2 to the 5th, well, that equals 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2 times 2, right? But look, 2's cancel out, 2's cancel out, 2's cancel out, 2's cancel out, 2's cancel out. So am I left with 0? No, I am left with 1, right? Remember, anytime you divide a number by itself, you get 1. So if 2 to the 5th over 2 to the 5th equals 1, but 2 to the 5th over 2 to the 5th also equals 2 to the 0 power, that means 2 to the 0 power has to equal 1. That's the big part of the day, guys. One of them. 2 to the 0 power equals 1. So that's telling me and telling you guys that any number to the 0 power is always, always, always going to equal 1. So let's write that down. A to the 0 power equals 1. Easy, right? I don't like that one. I'm just going to put 1. And I don't know what this mark is here, so I'm going to get rid of that. Okay, now a to the negative m. Watch this. 2 to the 6th power over 2 to the 8th power, right? So that's going to be 2 to the 6 minus 8, which equals 2 to the negative 2 power. But remember, 2 to the 6th over 2 to the 8th is just 2 times 2 times 2 times 2 times 2 times 2. That's 6, right? Times 2 times 2 times 2 times 2. Oops. Times 2 times 2 times 2 times 2 times 2, right? That's 8. So now, what happens to all the 2's? Cancel, 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 cancel. But look, there's not enough, right? So that equals 1 over 2 squared. So notice, 1 over 2 squared equals 2 to the negative 2 power. So a to the negative m is 1 over, it's always 1 over, and then you just change the sign and put a to the m power. So a to the negative m is equal to 1 over a to the positive m. Notice this negative 2 right here became a positive 2. And this number 2 stayed the same. You just moved it to the denominator. So put it in the denominator, change the sign. Done. That's what we will be doing today. I know it's tricky, but these are the 2 important rules that we need to know today. So let's do an example. 5 to the 0 power, right? 5 to the 0 power, you guys should know 5 to the 0 power, anything to the 0 power equals 1. Done. That should be the easiest homework assignment ever, right? Homework question at least. 9 to the first times 9 to the third. Well, that's going to be 9 to the 1 minus 3, which is 9 to the negative second power, which equals 1 over 9 to the positive second power, which equals 1 over 81. Remember, guys, it says to evaluate, so I need an answer. This next one, 1 over, right? Because 1 times 1 is 1. Now we need to do m to the 8 times m to the negative fifth. So that means I need to do 8 plus negative 5. Well, 8 plus negative 5 is 3. So therefore, I get 1 over m to the third power, and I'm done. Done. 8 plus negative 5 is 3, so you just put m to the third. For the next one, I need to do 2 plus negative 6, right? Because I'm adding the exponents because I'm multiplying. So 2 plus, oh, sorry guys, I kind of said the answer. 2 plus negative 8. 2 plus negative 8 equals negative 6. So therefore, I know this equals e to the negative 6. But you cannot leave this as a negative exponent. You don't leave negative exponents, right? So instead, we're going to change it to a positive exponent. So we're going to put 1 over e, but remember, it's not negative 6, it's positive 6. 1 over e to the 6th is your answer. E to the negative 6 is the same as 1 over e to the positive 6. So let's do couple more examples, and notice it says positive exponents only. We want to make sure we always have positive exponents. We don't like negative exponents. We hate negative exponents. So what we're going to do, we're going to change them so that they are positive, right? So A, simplify the expression using only positive exponents. Well, A is done. 5m squared. There's nothing you can do with that. So we're just going to put 5m squared. But now, for B, it's not simplified all the way. Notice we need to take this 2 to the 5 and also take the 2 to the m. So that's going to leave me with 5 squared m squared, right? So 5 times 5 is 25, so your answer is 25m squared. 5m to the negative 2. Notice this negative 2 does not go to the 5. The negative 2 does not go to the 5. So we leave the 5. And then remember, m to the negative 2 is the same thing. Hang on, let me box this. M to the negative 2 is the same thing as 1 over m squared. So that's just 5 times 1 over m squared. But if we change 5 to 5 over 1, this is going to equal 5 over m squared. That's your answer. And then the last one is 5m to the negative second power, the whole thing. So we need to take both of these. So therefore, we have 5 to the negative 2 power times m to the negative 2 power. Well, 5 to the negative 2 power is just 1 over 5 to the positive 2. And m to the negative 2 is 1 over m to the 2. So therefore, 1/5 times 1/5 is 1 over 25 times 1 over m squared. So our answer is 1 over 25m squared. Yep, 1 over 25m squared is going to be your answer. All right. Couple more examples. They look really intense. I know, guys. I know. really intense. But I'm going to show you a quicker way. I think it's a quicker way to do these. All right, let's look at A. I have A to the second power, and I have A to the fifth power. So are there more A's on top or on bottom? There's more A's on bottom, right? So this is A times A, and this is A times A times A times A times A, right? So I cancel two of them out, so there's still three A's on the bottom. So instead of that, what I'm going to do is I'm just going to cancel out, and let's go back a little more. Let's go back all this. So what I'm going to do, I'm going to take off this A because there's only two of them. And then I'm going to take off this 5. And what did we say we had before I erased? We had 3, right? So I'm going to change this to a 3. Okay. Now, after I change it to a 3, let's do the B to the 7 and B to the 6th. Well, there's more B's on top. How many more B's on top are there? 1. So I'm going to get rid of this B. I know it's kind of sloppy. Get rid of the B. Get rid of the 7. How many more B's are on top? 1. So our answer is B over A cubed. So let's go back. And our answer is B over A cubed. And the reason is there's one more B on top. That's where that B comes from. And there's 3 more A's on bottom. That's where that comes from. Let's do the same thing for example B. So this is going to equal blank. So are there more A's on top or on bottom? There's more A's on bottom. How many more A's on bottom? Excuse me. How many more A's on bottom are there? There's 6 more. There's 2 on top, 8 on bottom. There's 6 more on the bottom. Let's look at B. Remember, this is B to the first. Are there more B's on top or more B's on bottom? Well, there's more B's on top. How many more? 2 more. For C's, there's only C's on top, so I'm going to leave it as C to the fifth. So therefore, my answer is B squared C to the fifth over A to the sixth. That's how I would do this. For the next one, put my fraction sign A to the fifth over A squared, where there's 3 more A's on top. B cubed over B. This one's pretty similar. B cubed over B. Well, there's 2 more B's on top. And then C squared, well, that's on top also. So I don't even need my fraction bar, right? A cubed, B squared, C squared is my answer. Last one. This is kind of weird, right? A to the negative 8th is on bottom, right? Think about it. If A to the negative 8 is on top, it flips and becomes 1 over A to the 8th, right? But if you have 1 over A to the negative 8 on top, it flips and A to the 8th over 1 becomes on top. So you are always just flipping it and then making the sign positive. You're flipping it and making the sign positive. So what we're going to do here, we are going to rewrite this, and we are going to have 24 A to the negative 4th, B to the negative 5th, but we're going to change this A to the negative 8th and put it on top, but make it A to the positive 8. That's the same thing. And that's going to be over 8B. So now what we're going to do, we're going to simplify. So I'm going to get my fraction bar. 24 divided by 8 is 3. Let's look at the B's now, right? So B to the negative 5th and B, you know what? We're going to try this a completely different way. Let's do this a completely different way, guys. I have an idea. I think this way, I was going to do one way. I like a different way more. So what we're going to do instead, and we don't like negatives, right? We hate negatives, right? I was saying our answers always have to be positive, right? It says only positive, right? Or is this only positive? All right, so instead, let's get rid of all the negatives first. So what I'm going to do, I'm going to rewrite it, and I'm going to put 24 in my fraction bar. But a to the fourth, I don't like that. So remember, I can just move it to the bottom and make it positive. So I'm going to put a to the fourth instead down there. Now b to the negative fifth. So I did the 24. I did the a to the fourth. B to the negative fifth. I don't like that on the top because it's negative. So I'm going to move it to the bottom and make it positive. Right? So now I finished the top. Let's look at the bottom. So 8 stays the same. A to the negative eighth. I don't like that. So I'm going to move it to the top and make it positive. And now I'm just going to put another b because that's in the right spot. So now I can simplify because we have all positives. So 24 divided by 8. So 24 divided by 8, that simplifies to 3. A to the 8 over a to the fourth. Well, there's 4 more a's on top. So I'm just going to put a to the fourth so I can cancel those out. And then I don't have any b's on top, so I don't subtract. I have a b to the fifth, and I have a b to the first. Well, b to the fifth times b to the first, because remember, this is multiplication, so we need to add those exponents. B to the fifth times b to the first. There's 5 b's on the bottom. There's 1 more b on the bottom, so there's 6 b's on the bottom. So b to the sixth. We don't move it to the top. We don't do anything with the top because there are no b's on the top, and b's already positive. So this is your answer, guys. 3a to the fourth over b to the sixth. I think that's a better way. You always want to change the problem, manipulate the problem so that there are no negatives anymore. Once you're only stuck with positive exponents, then you can start simplifying. Hopefully that made sense. If not, we're going to do a couple more examples real quick, and then we'll be done. All right, I'm pretty sure this is the last example. So simplify the expression, only positive exponents again, right? So h to the negative 2 power. Remember, that's the same exact thing as flipping it and putting it on the bottom. So the reason I say flipping it is because remember, any number you can put over 1, right? So now let's flip it. 1 over h to the negative 2. But we can't just flip it. That'll change the values. So we flip it, and then we switch the sign right there. 1 over h squared, done. Here, notice we have the same base, and this is multiplication. So we need to do negative 9 plus negative 2 plus 6. Well, that's negative 11 plus 6 is negative 5. So therefore, our answer is m to the negative fifth power. But we can't leave it like that because it says positive exponents, right? Positive exponents. So instead, we're going to do 1 over m to the fifth. And then you get your answer, and you are done. All right, last one right here. Remember, I don't like negative exponents, so we're going to change it so we only get positive exponents. So first, I'm going to ignore this part. I'm going to kind of just ignore that part. We're going to go back to it. Okay, let's look right here. Let's look at this part right here, right? So I don't like that a squared, so I'm going to change that a to the negative second power, and I'm going to put it on the bottom, right? But I'm going to change the sign so that it stays the same, right? And then a to the negative third, I don't like that on the bottom because it's negative, so I'm going to flip it to the top. So now it's a cubed. So therefore, I can rewrite, let's see. Therefore, I can get rid of this. Hopefully this doesn't take too long. I can get rid of this, and I'm going to write a cubed over a squared, right? I'm going to write a cubed over a squared. So this is going to be times. Let me get a better pen for this. 8 times a cubed over a squared. So now I can multiply across. I have a 2, a 3, and a 3. So a to the fifth, that's going to end up a to the eighth. How I got a to the eighth? 2 plus 3 plus 3. Remember, I'm adding, right, because I'm multiplying the numbers together. On the bottom, this is an a to the first, so I have a to the fifth, to the first, to the second, so 5 plus 1 is 6. I end up with a to the eighth, right? So therefore, my final answer, a to the eighth divided by a to the eighth, if you divide the same number by itself, you just get 1. So let me go back, and I'll show you that the final answer equals 1. So the final answer here equals 1. I think that's a lot easier, just simplifying, right? All right, your homework, 4 through 26 evens, last homework of the section. So you guys have a good rest of your week. If you have questions, let me know. Please, please, please let me know, and I will talk to you guys later. See you, challengers and girls, later.